Test review chapter 1 on the basic concepts of algebra. So we're going to go through a few sample types of questions on the basic concepts of algebra. So question 1. Find the two consecutive integers in which the non-perfect square falls. Then choose the closer integer. So the first thing we want to do is just first verify that they're not perfect squares. So 175 is not a perfect square. So we want to find the perfect square right before 175. And the perfect square right before 175 would be 144, which would be 12 squared. But then I could also do 13 squared, which would be 169. So let's do the square root, or a negative. Can't forget about the negative. So the negative square root of 169. And then the other one would be 14 squared, and 14 squared would be 196. So I would have a negative square root of 196. And now I got to think, what number is closer to 175? The number closer to 175 would be 169. So we're going to find square root of 169, which we said was 13. So right now we know it's between negative 13 and a negative 14. But a negative 13 is the closest value. Now if you want to, you can always go to your calculator and we can just type that in. So negative square roots of 175. And that gives us a negative 13.22 and so on. But negative 13 would be the closest integer. Next one is the square root of 45. So the perfect square before 45 would be the square root of 36. And then the one above it would be the square root of 49. And 49 is closer to 45. So we know right now the square root is going to be between 6 and 7, but it's going to be closer to 7. Question 2, determine if each set of numbers is closed under the indicated operation. Include a counterexample if it's not closed. So we have whole numbers. So this is saying if I take two whole numbers and I add them, I'm always going to get a whole number. That is true, so we're going to write closed. And the second one, natural numbers for subtraction, which means if I take two natural numbers and I subtract them, will I always get a natural number? The answer is no, so this is not closed. And now I have to provide a counterexample. So if I take natural numbers, which are my counting numbers, so if I took, let's just say I took 3 and I'm subtracting 5. 3 minus 5 is a negative 2. Negative 2 is not a natural number. Question 3, find the sum or difference. So here I have negative 8.5 minus 6.2. Since the first number is negative and I'm subtracting the second number, I'm really adding the opposite. So I'm really adding two negative numbers together. So I have 5 plus 2 is 7. And 8 plus 6 is 14. But since they're both negative, my answer is negative. So a negative 14.7. Next, I have 5/6 minus a negative 3 1/3. Now for this, I'm going to put this as improper fractions. But first, I'm going to add the opposite. So really, I'm adding two positive fractions. So I have 5/6 plus, and this is going to be 10/3. But when I add fractions, I need common denominators, and the common denominator of 3 and 6 is 6. So I multiply by 2 over 2, and I get 20 over 6. Now I can add them together. 5 plus 20 is 25. The denominator stays the same, so 25 6. I cannot reduce any further, so I would just leave it as an improper fraction. Question 4. Two numbers have sum of 5 and difference of negative 15. What are the numbers? So if I have two numbers, so I'm just going to say one is x and the other one is y. So if I add them together, it's going to give me 5. But if I take those same two numbers, x minus y, it's going to give me a negative 15. So that means I know one of the numbers has to be a negative number. And I know that my x is going to be a negative number because if let's just say I have x being negative 10. So if x is negative 10, that means in order to get this to be a positive y, actually x is going to be negative 5. So if x is negative 5, y is going to have to be 10. Because now if I did negative 5 plus 10, that gives me a positive 5. And if I did negative 5 minus 10, that gives me my negative 15. So my two answers, or my two numbers, would be negative 5 and 10. Question 5. Find the product or quotient. So here we're going to be looking at the sign that they're using. So this first one, they're dividing. Remember, we can't divide by a decimal, so we have to multiply by a power of 10. So I multiply this by 10, and I multiply the dividend by 10. So now I really have 13.6, and I'm dividing that by a negative 2. Negative 2 goes into 13 a negative 6 times. Negative 6 times 2, negative 2 is 12. I subtract below and I get 1, bring down the 6. Negative 2 goes into 16 8 times. I also have a decimal point there. 8 times negative 2 is 16. So I don't have a remainder left. So the solution would be a negative 6.8. Next, here I'm dividing fractions. So I'm going to put them in improper fractions first. So 8 times 2 is 16 plus 1 is 17. So I have 17 eighths. And when I'm dividing with fractions, I'm really multiplying by the reciprocal. So this one is actually a negative 12 plus 3 is 15. So negative 15 fourths. I have to flip it. So it'll be a negative 4 over 15. And then from this point, I would just simplify diagonally. So I can divide a 4 here and get a 1, divide a 4 here and I get 2. Now I can just multiply straight across, and 17 times 1 is 17. 2 times negative 15 is negative 30. I don't have any common factors in the numerator and denominator, so my answer would remain as negative 17 thirtieths. And letter C, there we're just multiplying. Again, I'm going to put this as improper fractions. So 5 times 7 is 35, plus 1 is 36. So we have 36 fifths. And we're multiplying by 2 times 3 is 6, plus 1 is 7. So this is negative 7 halves. Now if I look diagonal, 2's can divide out. 36 divided by 2 gives me 18. And now I'm left with 18 times negative 7. I'm just going to grab my calculator quickly. So we have 18. We're multiplying that by negative 7, which is going to give us a negative 126. And that's all going to be over 5. Number 6 says simplify the expression in standard form. So standard form, remember, is just the exact answer. So we're not going to have any exponents in our answer. So we have 2 squared, which is 4. Negative 2 to the negative 4th power, which means I have to flip the base, so it's 1 over 2 to the 4th power, which is 1 over 16. And then 2 to the 6th power would be 64. And now I can simplify here. I know that I can take 16 divided by 16 is giving me 4, or is going to be 1. And 64 divided by 16 is going to give me 4. Now I have 4 times 4, which is going to give us 16, and that's our answer. Now if you want to verify on your calculator, we can just put this in here. So we got 2 squared times 2 to the negative 4. And then we're going to multiply that times 2 raised to the 6th power. And that gives us our 16, which is what we just said we had. Letter B, 4 squared is 16. 2 squared is 4 times 6. So we have 24 times 16. Again, we'll use our calculator. 24 times 16. That gives us 384. And then we have this last one. We have 5 to the 5th times 5 to the negative 4th. When we multiply like bases, we add the exponents. That's going to be 5 to the 1st. And the denominator, we have 5 to the negative 2nd times 5 to the 3rd. Negative 2 plus 3 is 1. So we have 5 to the 1st power. And when we have common denominator or common bases and we're dividing, we're going to subtract the exponents, which means we have 5 to the 0 power, which this whole thing is going to equal 1. Moving on to question 7, we're going to simplify this using order of operations. So we need to simplify the numerator first, and we're going to follow PEMDAS. So parentheses first, 4 minus 6 is, or 4 minus 10 is negative 6, and negative 6 squared is 36. Plus, we have exponents, so 25 squared gives us 625 divided by 10. And since we have to do division first, on here we have 625 divided by 10, which is 62.5. So we're going to grab our calculator. We got 62.5. And we're going to add 36 to that. And that's going to give us an answer of 98.5. Now the denominator, we have parentheses and we got brackets, so we got to go work on our inside out first. So we got 3 minus 5, which is negative 2. Then we multiply that by 9. Negative 2 times 9 is negative 18. And then we have negative 18 squared, so we'll grab our calculator. And we have negative 18. And then we're going to square that. And that gives us 324. And then we're going to be subtracting 3 squared, which we know is 9. And 324 minus 9 is going to give us 315. Now we can do our division. We'll just take our calculator here. We got 98.9 or 0.5. And we're going to divide 315. That gives us a long decimal. Let's see if we can change that to a fraction, which it will give us to a fraction. So I would just keep it as a fraction. And our fraction would be 197 over 630. And that's a reduced fraction. Question 8, simplify and write your answer in scientific notation. So for here, we have to take the decimal parts and we need to multiply those. So we'll grab our calculators again. So we have 4.8, and we're going to multiply that by 2.5. That gives us 12. So right now we got 12 times 10. 10 to the 4th times 10 to the 8th is 10 to the 12th. Because remember, we multiply like bases, we add the exponents. But our answer has to be in scientific notation. So I have to move the decimal point one place to the left because I gained a decimal place I need to show that I gained an exponent. So this would be 1.2 times 10 to the 13th. And letter B, here we need to divide first. So we're going to take 3.278, grab our calculator again. So 3.278, and we're going to divide that by 4.4. And that gives us 0.745. But I want to put that in scientific notation, so that's going to be 7.45, and I lost a decimal place, so I got to keep that in mind when I do the division here. So we have 7.45, and this is going to be times 10, and when I divide like bases, I subtract the exponents, so that's going to be 7, but since I lost a decimal place, I have to lose an exponent, so that's actually going to be 6. Then I can now add 3.8 times 10 to the 6th, and 3.8 plus 7.45. So let's do 7.45 plus 3.8. That's going to give us 11.25. And this is going to be times 10 to the 6th, but this is not in scientific notation. I need to multiply it by 10. So this is going to be 1.125 times 10, and since I gained a decimal place, I gain an exponent, so that would be 10 to the 7th. So that would be our answer in scientific notation. Question 9. Write an algebraic expression for the situation. Max gives an equal number of cards to 8 friends. If he gives C cards, how many does each friend get? So he divides that out. So this is going to be C divided by 8. And letter B, 15 more than the quotient of 17 and D. So 15 more than, which means I'm going to be adding 15. Well, when am I going to be adding 15 to? Well, the quotient, and quotient is the answer to a division problem, so I'm dividing 17 and D. So our expression would be 17 divided by D plus 15. In question 10, evaluate the expression for x equals 4 and y equals negative 2. So I'm just going to substitute those values in. So right now I got negative 2 squared minus a negative 4. And this is going to give us negative 2 squared is 4 minus a negative 4, which means I'm really adding 4, which is going to give us 8. And then the next one, I got 2 times 4 minus 4 times negative 2. And I'm going to subtract this, would be negative 2, actually 4 squared, and then negative 2 squared. So now if I simplify this, 4 minus 4 times negative 2, which really means I have 4 plus 8. 4 plus 8 is 12. 12 times 2 is 24, minus 4 squared is 16. 16 times 2, negative 2 squared, which is 4. So 16 times 4 is 64. And then I subtract those. So I'm going to treat this like 64 minus 24, which is going to give me 40. But since 64 has a bigger absolute value, I go with that sign. So it's in negative 40. Next, substitute the number in for n to make the statement true. Identify the property being used. So in order for I have negative 96 times a number to get negative 96, I know that n has to equal 1. And the property would be the multiplication property of 1. So it means anything times 1 is itself. In question 12, we're going to use the Venn diagram here to answer and find the specific set. So we have to put it in roster formation, so that means we're going to have braces. So this one, it says A intersects with B and intersects with C. So that has to be, all the numbers have to be in all three circles. And there's only one of them that's in all three, and that is 15. And our last question, add in and multiply the matrices. So this first one, I have 3 plus 2 times 3. So I have to distribute. So let me distribute this first. So this is going to be 6, negative 4, 2, and 4. Then I can add these together. So 3 plus 6. 3 plus 6 is 9. Negative 2 plus negative 4 is negative 6. Negative 1 plus 2 is 1. And 3 plus 4 is going to give us 7. So our answer would be 9, negative 6, 1, 7. And our last one here, we are multiplying. We got to verify that we can multiply it. And this is a 2 by 3. And this is a 3 by 2. Since this middle two are the same, my answer is going to be a 2 by 2. So to find this number, I'm going to take row 1, column 1. So 1 times negative 5 is negative 5. Negative 1 times negative 1 is 1. And 1 times 0 is 0. So if I add those up, that gives me negative 5 plus 1 plus 0 is going to give me negative 4. Next, this is row 1, column 2. So I have 1 times 1 is 1. Negative 1 times 2 is negative 2. And 1 times 5 is 5. And if I add those together, 1 plus negative 2 is negative 1. Negative 1 plus 5, or 5 minus 1, is 4. Next, I'm in row 2, column 1. So we got negative 2 times negative 5, which is 10. We got 0 times negative 1 is 0. And we got 0 times 0 is 0. So if I add those together, it gives me 10. And this last one here, row 2, column 2. Negative 2 times 1 is negative 2. 0 times 2 is 0. And 0 times 5 is 0. So that's going to give us a negative 2. So that would be our answer for our multiplication of the two matrices. So that is a quick review of chapter 1, looking at the basic concepts of algebra.